Hey, Voxic here. So I'm making a game inside Minecraft with Skript. If you don't know, Skript is a plugin that lets you write in interpreted language, so it's not compiled or anything, unlike Java, because Java is cringe and scripting languages are based. So I'm making this game, and within it, I'm using a custom resource pack, and I'm using display entities and stuff to represent bullets or abilities or props that are around the map, and I want to check like collisions with them. I want to see if they're destroyed by any abilities, and I don't want to have to loop over every single object that exists in the game to just check if I hit the things that are next to me. So how do we solve this? Well, the solution that I've decided on is Octrees. And if you don't know, the problem is called spatial partitioning. Partitioning is basically, you might have heard of that, you might not have, but you might have heard of that in relation to hard drives. And a hard drive has to split up, it can hold however many gigabytes of data, and it allocates those, meaning it creates, you can imagine, a cube inside of it that contains these bits, and it can only be used by that area. It's like how you type /C when you have different drives on your computer. So what this looks like in game, so let's go ahead and create one. So create an octree, and we just said that, hey, this is our game area. Everything happens inside of here. And right now this is gray because it doesn't contain any objects. So if we ever wanted to check nearby objects, well, we can immediately stop because there are none, right? Pretty simple. But it gets complex once you start adding objects. So if we have these two objects and we want to check every tick if they're overlapping, because that means they hit each other and maybe they blow up, or these are two players and this one is using an ability to damage all other players that are within 5 blocks. Well, that's pretty simple. We just loop over all the entities and check their distance, to that player. And if it's below 5 blocks, boom. But that's kind of inefficient because let's say we have just a ton of players and then we just have one player over here. We don't want to, we want to skip this player. So let's go ahead and see how an octree would handle that. So I've gone ahead and set a rule that anytime that there's one of these square regions, right, a node within the octree, if there's ever more than 2 entities, let's go ahead and split it. Let's evenly split it on each axis. Let's cut it in half. So it'll turn it into 8 smaller cubes. And it'll keep doing that until it fulfills the rule that that there's only maximum of 2 entities. So let's go ahead and add one. Cool. So as we expected, it split it on all 3 axes, 8 cubes, why it's called octree. And now, anytime we want to check, interactions between nearby entities for, say, this player, we just loop over all of these, and it's like, that one doesn't have players, that one doesn't have any players, no, and that one, okay, well, check that whole region. Does this whole region overlap with the area that we want to check? No, it doesn't. So we skip everything inside of there, and vice versa. This player would skip everything inside of there and continue its checks. That's pretty efficient, right? Now, what if we have more players? Well, we just do the same rule over and over. Now we have 3 here, and it split them into 2 boxes. And this doesn't have more than 2, doesn't have more than 2. Now the rule is satisfied. So if we go ahead and add another one here, it does it again. And if we just add a bunch, eventually it gets so small where it's like, are we going to keep going infinitesimally? I don't know how to say that word, small. No, we're not. We're going to stop at I've set another setting, and it says, just keep doing that rule over and over. But if the regions get smaller, then don't let the regions get smaller than, say, 2 blocks. I just chose that randomly to visually show it. It's a little nicer that way. But once it gets down to that point, it says, okay, fine, you win. I'll have more than, 2 objects in this box. And that's okay, because there's a lot going on there. And every game, might have a different setting for that. But if we go ahead and zoom out, now, at first it's like, well, looping through everything here and checking its interactions between every other, object, that's okay. It doesn't take many resources. Computers are fast these days. But the cool thing is that this is just a very small scale. We can have tons of these objects, You could just have hundreds of these objects all interacting. And now you've created these isolated regions where everything over there never has to check everything over there. At this higher level, this big box, once it checks the first 8 smaller boxes that are contained within it, it eliminates all the other 7 and only checks now these 8 sub boxes over and over. And yeah, if you're interested in learning more about this topic, just Google Octrees. Another keyword would be spatial partitioning, also known as spatial hashing. It's really interesting stuff. There's a lot of cool solutions, but I found this to be the simplest to understand and implement. So yeah, let me know what you think. This is all, vanilla in Skript. So no Java code. Java's cringe. We hate Java. If you're compiling in 2023, what are you doing? But and then a custom resource pack with a shader to draw these lines. But yeah, hope you enjoyed. Hope you maybe learned something new. Peace.